I welcome you for the Ansys lab videos. So in this lecture I am going to tell you how to solve the two element truss problem which are having different areas. See, if I assume this is my first element, and the respective area is 1200 mm square, and if I am going to assume this would be my second element, here it is written, and area is 1000 mm square, and the load is acting 50 kilonewton here, and E is given 200 GPa. So this length is 500 and this length is 750. As usual in the problem, usually Poisson-Schuster value will not be given. So that value we have to assume either 0.27 or 0.3. So okay, let us solve the problem using Ansys software. So structural, preprocessor, element type is open, add, click add, link, okay, close, material properties, material models, structural, linear, elastic, isotropic. So what is the E value here? So E value is 200 GPa, fine. So 200 GPa. See this friends, so either we have to follow in mm or in meter. So whenever we are defining nodes, if I assumed unit is mm, then nodes should be also defined in mm itself. Okay, so close. So come to the software. So material model is given, section. So link, because why I am going on link, because in the element type I have considered link itself. Link, add, so click OK. So what is the first area? First area we know that it is 1200. See here, the first area is 1200 and second area is 1000. Okay. So this is the rise hidden option. So if something is been hidden, so if I come and click here, so it will reappear. Apply. So I'll change 1 to 2. Okay. And now I'm typing area is 1000. Yes. Okay. So next is modeling. So before modeling, see, look at here. So from, if I am going to assume this is my reference node. So from this to this, where is this node? X is 750, Y is 500. And where is the third node? X is 0 and Y will be 500. Obviously the first node will be 0, 0. Okay. On nodes in active CS, so first node always it will be 0, 0. Second node will be 750 and 500. So rise hidden option, 750 and 500 is the second, apply, and third one is the just 500. It is in the Y direction. See, 1, 2, second is here, but it is not visible. 3. So the 3 nodes are being created as shown in the figure. So now element attributes. So as already explained in my previous lecture, here I have to come and cross check. Material number will remains 1 because only one E value is given. If there would be a 2 E values, then here it will be showing 192. Okay, so let us cross check with section numbers. Yes, section numbers I am getting 192 because I had given 2 areas. One is 1200 and the second one is 1000. Okay, so first, for the first element, I have to choose, I have to keep it as material number is also 1 and section number should be also 1. Okay, through nodes, this, just to come and pick, yes, their node is there. Just give OK. So now next come here and change 1 to 2. If you do not change this, then for both the elements your area 1 is going to take. That is wrong. Okay. So let me cross check once again. Yes, it is 2. Okay. Through nodes, click this line, this, say OK. Okay. So now I have to go for loads. Loads. Define loads. Apply. Structural displacement is on nodes. So coming to the boundary condition, first node and third node are fixed. So pick this, okay. So choose all DOF, all degrees of freedom. And now force is how much? So the force acting is 50 kilonewton here. The force acting is 50 kilonewton here. Okay. Fine. Sorry. Yes. On nodes, choose this and give it as in Fy direction, it is minus 50 kilonewton minus 50,000. Okay. So let me cross check once again the force value as minus 50 kilonewton. So now I have to solve the solution, solve current LS. So now as I got the window solution is done. Fine. As I already told in my previous lecture, to see the results only there will be two options. One is plot to get the diagram, other one is the list results to get the values. So first go to the plot results, nodal solution, displacement vector sum. So this would be the displacement diagram. So before going to save, so style, color, reverse video. Okay. So then plot controls, capture image. So save this image any name for your convenience. Okay. So next is here next is I have to define the element table. Just I am showing you. I will be getting error now. By sequence number ls is 1. I do not write anything. See here I am getting error. So to resolve this error, I have to type the yes. To remove this error, so I have to type set comma all and hit enter. Hit enter. Now you come and define cross check element table add by sequence number. ls means it is stress. So I am writing stress here. Stress. Okay. So next come here add by sequence number. LEPL means strain. So type strain here. Okay. So stress and strains are being created. Now to plot the results, I mean why I am using plot option to get the diagrams. Line element results, stress is selected. So this would be the my stress diagram. Okay. So this would be my stress diagram. Similarly to get the strain diagram, see here, this would be my strain diagram. Okay. So values are changing here. Diagram will remain same, but values are changing here. So for strains 0.376 10 to the power minus 3z, but let us cross check for stress. It would be 75 minus 75 plus 75. Okay, fine. Now to get the values, go to the option code as list results, nodal solution. Okay, so these are my displacement values. See here, I'll prove you node 1 and so since stress is at 2 degrees of freedom, every node will be having 2 degrees of freedom. U1, U2 0, U5, U6 0. So I have to get only U3, U4 as the values. Cross check. So this is the node numbers 1, 2, 3, U1, U2 0, U5, U6 0. So I am getting in at U5 and U6 value. So these values are correct here. Okay. So U3 is 0.28125 and U4 is minus 1.0322. Okay. Fine. So next node, here element table data. To get the stress, just click on stress. Minus 75 and plus 75 are the answers. Stress sigma 1 is minus 75 and sigma 2 is 75. Again click on the element table data, select only strain. So these are the strain values. If you want both together, click stress as well as strain. So these are stress value and these are the strain values. Okay. And the last one is reaction solution. All items. See, as I already told you that always reaction solution will be equal to the sum of the load applied. So minus 75,000 plus 75,000 goes away, it will become 0. And here I am having plus 50,000. But the load applied is minus. As I already told you that the reaction solution will be always equal to the sum of the load applied but will be in the opposite direction. Their load is negative, here I am getting positive. Thus, all the answers are correct here. Okay. So thank you friends. Thank you for watching. Have a good day.